Okay, right here we're going to be looking at radicals and rational exponents and the relationship of these two things together. Our objective today says, hey, I can simplify radicals and rational exponents and convert them between the two. So we can go backwards and forwards and forwards and backwards. Rational exponents. I have here example x is to the a over b. That is a rational exponent. It's just a fractional exponent. The denominator of the exponent is our root for our radical, and the numerator is the exponent that would go with the number or variable inside the radical. So looking at our examples here, it says, hey, let's go and write these as a radical. So the first one they give us is 2 to the 1/2 power. 2 to the 1/2 power. Remember, my denominator is my root, so that's going to be a square root. And we don't put a 2 there because it's understood with this symbol that 2 is automatically there. Anything other than a 2 we would have to put there. They do have a 2 here, so we're going to go ahead and be consistent with our paper, but it's not necessary. And then it's 2 to the first power, or just 2. Looking at the next example, my denominator this time is 3, so you do have to put the 3 there as my root. The 3 is the root. Tells me it's the third root of x to the second power. Writing them in radical form. We can go the other direction with them, which sometimes is better to have them as exponents. Here we have the square root of 4 to the third power. So this one becomes 4 to the 3 over 2 power. That's my denominator. Okay, it goes on the bottom. Denominator. Ooh, didn't want to spell right there. And then the other one becomes the numerator then. For this example here, I have the 6th root. So I have x to the 5 over 6 power. Switching back and forth between exponents and radicals using our rational exponents. So moving along here, it says, hey, let's go and simplify these things. So I need to go and figure out what these are in their lowest terms. So I have 81 to the 3/4 power. Well, 81 to the 3/4 power. Oh man, we got a lot of thinking to do about this one. What are we going to do? Well, 81, I could think of this really as 81 is really 9 to the second power raised to the 3/4 power. I could do that, right? Because 9 to the second power. So remember our rules for exponents? Our rules for exponents tell me that, hey, if I have a power on the outside like this, I have to multiply these together. So if I multiply these together, this one here becomes 9 to the, well here I'm going to, if I multiply this together, this is like saying 2 over 1 times 3 over 4. Remember, whenever you're multiplying with fractions, you can simplify these before we multiply. So I now have 9 to the 3/2 power. 9 is really just 3 to the second power. So I can go through and do this again. So I'm going to take and multiply these two together again, right here. So I'm going to have 2 over 1 times 3 over 2. Doing this right here, I can simplify again, making this a 1 and a 1. So I now have 3 to the third power. 3 to the third power is 3 times 3 times 3, which is 27. Now, is that the only way to simplify these? No. We're going to look at another method to simplify when we look at our second one right here that says 32 to the 3/5 power. So thinking about this one right here, I could think of this as in terms of a radical. I got the 5th root of, inside here, 32 is really 2 to the 5th power raised to the 3rd power. Or it might be better to think of it like this: 32 to the 3rd power. Which then becomes the 5th root of 2 times 2 times 2 times 2 times 2 raised to the 3rd power. Well, if I have 5 of these here and a 5th root, those two things are the inverse of each other. So I now have 2 to the 3rd power, which is 2 times 2 times 2, or 8. And this is a grand method as long as you don't have a whole great big bunch of stuff. The larger the numbers, the worse that method goes to use, and it's better to use like we did on the first example. Our example down here at the bottom, we're dealing only with variables, so we want to convert these things into x to the 1/6 times x to the 1/3. Remember, whenever you're multiplying with these, we have to take and add our exponents. So this will be x to the 1/6 plus 1/3. I'm going to take this little piece right here, separate, and bring it down here and do 1/6 plus 1/3. When we're adding fractions, I have to have a common denominator. My common denominator would be 1/6 plus something over 6 here, which would be 2, because I got to do times 2 times 2, multiply it by my magic 1. So I add those together and get 3/6, which is 1/2. So up here my final answer would be x to the 1/2 power, or the square root of x. Radicals and rational exponents. Make sure you pay attention to what you're doing and remember your rules of exponents as we are going through these things. Paying attention, keeping track of what you're doing will help save you a lot of time, headache, and heartbreaks. Good luck.